It is quite appropriate to give the presentation here. It describes my journey through computer security over the past 20 years, starting in Chris Mitchell's office when Chris, Fred, myself decided who would teach the 4 core modules on the MSc in Information Security for the first year starting in '92. And I won the battle of wills with Chris. I would teach computer security, which was the subject all of us knew least about. To give you my context, you have heard similar remarks in the previous talks. Security is a critical infrastructure, or IT, sorry, is a critical infrastructure. One example I've picked out here, air travel, having arrived on an aeroplane yesterday, having done my bookings over a web page, living in a world where paper tickets have officially been abandoned. I will move on to a conference starting on Monday. All the conference registration, hotel bookings, I do via websites, via email. It goes on to payment, credit cards, it goes to the ubiquitous communications infrastructure, which I refuse to participate in. I still do not have a mobile phone. There is something people in information security must know about. And then, of course, e-banking and the like. SCADA was mentioned directly, indirected in the last talk. Hence, the internet, the World Wide Web have become a critical infrastructure. And I will play on the word infrastructure throughout my talk. In essence, I'm trying to answer the questions, do we have to secure this critical infrastructure? Looking back at the first edition of my book, looking back at how I taught computer security in the 1990s, early 1990s, I was talking about infrastructure security. The course on computer security very much oriented towards operating systems. Process isolation, access control. Richard mentioned mandatory access control, Bell LaPadula in the talk before lunch. The frame of mind, once the operating system has given the data to an application, the job is done. Communication security, network security, you have seen it in Fred's talk, an infrastructure to take information from Alice to Bob. Once we've managed to do that with confidentiality, integrity, authenticity, our job is done. That is infrastructure security. A book, interesting book by Maury Gasser. Maury Gasser was with digital. I've reached the age when I can say I'm old enough to remember digital and fax machines. By the end of the 1990s, this was a cutting-edge, leading company, extremely successful company. By the early 90s, it quickly went down the drain. They had an excellent research group on distributed system security. If you look at their frame of mind, you have applications that is untrusted. We don't worry about applications. We provide a perimeter to the operating system together with the hardware. And again, Richard gave you the view from the 1980s that maybe we should rely on the hardwired pieces, not on the wobbly software for security. The trusted part down here. If you wanted to increase security, you would have a special security kernel, requirements on low complexity, requirements on formal verification. You've heard it before lunch. That was the view of the world at that time. And again, the applications up in the untrusted world, they were not security relevant. That would be topics that had dominated the first edition of my book: formal methods, reference monitor, discretionary access control, mandatory access control, security at the lower systems layers. The way we view it in the traditional fortress building paradigms we want to use: we retreat behind the walls into the castle. That makes us secure. Quick look at network security. You have Alice, you have Bob, there is the internet, and we all know the internet is completely insecure, and it's a cloud. I have read too many papers about insecure internet, exponential growth, and rubbish like that. Threat model: at that time, the adversary owns the network. This is the world Richard came from, the world of secret services, the military, the diplomatic services. Defense: cryptography. 1990s, when this MSc started, there was strong belief that cryptography would cure all our ills. And the major problem was the United States government with its export restrictions on keys longer than 48 bits. To reflect back on what Fred was saying, back mid-1990s, I was at an event at the Department of Trade and Industry where a gentleman from the DTI said it would be wrong to say that government is against the widespread use of strong cryptography. The situation is more difficult, he said. There are some parts of government that think the widespread use of strong cryptography would be a problem. There are other parts that think not using strong cryptography widely is the problem. That second opinion won by the end of the 1990s. The export restrictions went away. We now have the internet with strong cryptography, IPsec, TLS, SSL, as you had seen again in previous talks about virtual private networks. We have standard algorithms, DES, that still was the major algorithm back 20 years ago, officially superseded by AES, slowly replaced in reality by AES. In the world of public key cryptography, you see some move towards elliptic curve systems with hash functions. By 94, we had Hans Dobertin here at Royal Holloway to tell us why MD4 was thoroughly broken, predicting that MD5 was equally broken. It took the world a few years longer to believe that, but now MD5 is no longer acceptable in polite company. You at least have to use SHA-1, and we're waiting for SHA-3, that competition, to come up with the next generation hash function. I like to describe these again as infrastructure services for IT security. There are more fancy ideas: zero knowledge, direct anonymous attestation, in case you were wondering what DAA stood for. They have this dangerous epithet, promising. You have technologies that have been promising for many years, like antivirus tools. Concluding my view on communication security, we have strong protocols for creating secure channels. We are protecting against the Secret Service adversary. Again, to repeat my point, job is done when the message is being delivered. We do not look into the end systems. We're again providing a secure communications infrastructure for shipping bits, maybe higher level messages at the level of TCP, maybe higher level messages at the level of HTTP. At that point, a quick interruption. Who of you heard by November 2009 that SSL TLS was broken? No one paying attention. I am disappointed. It was widely reported. I'll have a backtrack comment coming up. The resource to look at would be a white paper by Ray Marsh, Steve Dispenser, Renegotiating TLS. And that allows me to move closer to our current IT landscape. You have an organization providing a website, providing secure access to a website. What they typically do, they allow you as a user to use SSL for anonymous connection, anonymous secure connection. When, during the session you have started, you try to do something that needs specific access rights, when you need to authenticate yourself, the trick they implemented was we use a feature of SSL TLS, session renegotiation, and in the new TLS handshake, we ask for mutual authentication. So at the end of the second handshake, we know who you are. That is the backtrack message, in case you believe I've invented everything myself. Multiple vendors, TLLs, protocol implementations are prone to a security vulnerability related to the session renegotiation process. My first PhD student at Hamburg, working at Airbus, sent me an email. Does this mean that we have to throw SSL TLS away? I will give you a very high-level overview of the attack. I will use Alice and Bob. There is an old talk by Professor Jim Massey, formerly ETH Zurich, formerly a coding theorist before he became also a cryptographer. If you don't use Alice and Bob, your paper won't be published in the cryptographic journal, which he found very strange because in communications it's A and B. They're able to think in abstract terms. To me, talking about the realities of today's web world, this is dangerous because if you look at a machine connected to the network today, there are protocols at different layers of abstraction. Collapsing everything into Alice and Bob loses important details, as you're going to see. So that is the pattern of the attack. Step one, Alice offers a hidden handshake to the server running the TLS handshake. Eve intercepts that as a woman in the middle, repeats that handshake with Bob. So Bob has a handshake with the person behind the screen. He is handed a letter, say, claiming to come from Alice. anybody could be behind the screen. So Bob asks for the screen to be removed and offers a handshake again. And now Eve disappears, lets Alice and Bob perform the handshake. That succeeds. He's been really talking to Alice, Bob thinks, and takes it for granted that the letter also came from the party. He's verified now. You have to look into the technical details to see how this attack is implemented in reality. When I looked at it, first observation, complaining about my dear friends, the cryptographers, they explain the rationale for renegotiation. You have been using this key for too long. You now want a new key that adds security. Web developers thus made the assumption that TLS renegotiation means that you are extending the previous session just with a new key. I read the RFC. You have the quote here. You can read it yourself. I did not find this assumption written down anywhere. Which allows me to hit out at the other end the Oasis W3C community that explains its web security, web services, web application standards with use cases. There was one particular use case. You want to have a new key because you no longer want to use the old key. That use case surreptitiously becomes something like a specification. People take it for granted. How do you fix the problem? You change the standard, not the expectations. That's what happened very quickly at the start of 2010 in this RFC. Conclusion. I do not see an infrastructure problem. I do not see a problem with SSL TLS. There was a problem the way the application guys used the infrastructure, didn't understand what the infrastructure provided, and were found out. Now, picking up Fred's earlier remarks, what has changed? What has changed in the 20 years? This MSc has been running the web. The web just emerged in the early 1990s. Static web pages. Nothing very interesting. Dynamic features being added by the end of the 1990s and more and more and more through the last 10 years. Web security. What does it mean then? Initially, when people still believed in cryptography, we encrypt the traffic across the network. We make our website secure by connecting to it via HTTPS. That means security. We have well-engineered solutions to do that. And you saw the project presentation here this morning, virtual private networks, and so on and so forth. You'd also heard comments, and I guess there will be more coming up on this weekend. The real threats, phishing attacks, social engineering, man-in-the-middle attacks, shoulder surfing, getting sensitive data from the server. One of my triumphs in life, I was on the main 8 o'clock news on German TV, first program, when Sony lost their data to some unknown hacks. These are all, and the last point, web application attacks. Cross-site request forgery, SQL injection, that is where the observed problems are. The attacker doesn't see a lot of internet traffic. The attacker is not Symantec doing all this monitoring with all these sensors all over the place. Target and systems users must not fall to phishing attacks, must be able to set up their own systems to a reasonable level of security. The software, early on, end of 1990s, when software security became a burning issue, the attacks at the level of networking system. Ping of death for those who remember. Today, badly designed web pages, no longer the infrastructure. And from 2005, 2006, 2007, buffer overruns, the low-level attacks, dropped down in the league tables of most frequent exploits. And application problems like SQL injection, cross-site scripting moved up. Side issue. I had been working for Microsoft Research in Cambridge. Very interesting place, very entertaining place. So I'm naturally positively inclined to this company. We had a security event in Hamburg 2-3 years after I'd left Microsoft. Invited speaker, Virgil Gleiger, very interesting gentleman at that time with Maryland University, now with CMU. He gave a talk about the history of information security. Is that there's a new problem coming up. It takes the research community about 10 years to understand it, solve it, reach mature solutions. Then they keep working on to the same old problem for the next 10 years still. But the actual problem have changed. So, I'm no longer interested in the Secret Service adversary looking at my traffic. I'm worried about an attacker misusing the functionality in my browser. What you have to know, in case you have not been looking into this area yet, there is a document object model, DOM. That contains in the browser typically information about the web page that's being presented by your browser. We have dynamic web pages, scripts in the browser, executed in the browser, typically JavaScript, scripts also executed at the server side, typically PHP scripts. How do I proceed as an attacker? I put my scripts in a web page. I send my scripts to the web page, or I put my scripts in a web page. You look at that web page. My script is being run on your machine. That is a new attack vector. That script might now try to connect somewhere else for historic reasons. First half to middle of the 1990s, Netscape and cookies, browsers enforce a so-called same origin policy. Script is only allowed to connect back to where it came from, for example. how does a script, or how does the browser connect on behalf of a script? The browser might be given a domain name and now has to look up the correct IP address, or one correct IP address for that domain name. That is, we're using the domain name system for access control. It was never meant for access control. I have good contact in Hamburg to the managing director of the computer emergency response team of the German research networks, who is quite involved in this community. When I ask him about particular features, he will tell you, well, Mocha Petris had this in his implementation and got it accepted in the RFC. That's how DNS grew, by the people running it, by the people wanting it to work properly in times when the world was good. In times, 1970s, 1980s, when you had only researchers connecting to the internet. Brief look at cross-site scripting. Participants, there is an attacker, of course. There is the client with a browser, the target of the attack. There is a trusted server. It is highly immoral to use the word trust in discussions about security. It means too many different things. In this case, it means access rights. Scripts coming from that server have more access rights than scripts coming from some arbitrary server in the web. The attacker might create a web page with a script in a frame. When you look at my web page, my script will be loaded into your browser. Your browser will be told, please go to this server and send this information to the server. If the server then sends that back, unfiltered, unchecked, in the response page, my script will be executed. That example here is from the first cert advisory on cross-site scripting. My claim to fame is Michael Rowe, who was at that time also with Microsoft Research in Cambridge, was sitting in the office next to me, and once in a while came over to my office to tell me something I only half understood, and then he went back to work on the problems around cross-site scripting. So by now, almost 10 years old. Another example, cookie stealing. The only thing you have to understand, document.cookie is part of the DOM, part of what your browser stores about the web page that's currently being displayed. And this piece of code gets the cookie and sends it to the attacker. We have a way of evading the origin-based security policy of the server. My script can be executed with the access rights of somebody else. Ultimate course, the client only looks at the last server that presented the web page. In a bulletin board example, which is the typical story about the so-called stored cross-site scripting attack, as a bad guy, I would place a script in my entry on the bulletin board. If you look at what I have to say, my script will be executed in your browser. Consequence, we were trying to run origin-based access control, but we can't even authenticate origin. We are doomed to fail. Defenses, filters. I would say it's the same story as in the talk before. It doesn't work. There is too much to filter for. Do you know about all dangerous characters? Do you know about UTF-7, UTF-8, and whatever else? Do you know about all ways malicious code might enter your system? There is one peculiar feature of cross-site scripting, DOM-based cross-site scripting, where the attack code doesn't come through the page itself, but through the URL. Do you know how filtered input will be further processed? When Mike Rowe was coming to my office, he was in particular complaining about Japanese character sets. In hiragana, the phonetic writing for Japanese syllables, there is a character ku, which looks like an angled bracket. And the story he told me later is, you have your filter. It looks out for angled brackets because angled brackets are evil. They might initiate attack. You see a ku character, which is not an ASCII character, something further down the Unicode list of characters. So you let it pass because it's obviously nothing to look out for. Further down the line, there is a software component that only understands ASCII. Some helpful guy has written a converter for characters that are not ASCII but look like ASCII characters. The non-ASCII characters are replaced by the similar ASCII character. So the ku character has sailed through your filter, gets converted into an angled bracket, and deep inside your code, you suddenly have a script tag. What I see happening more in the last year, not much more, targeted blocking of scripts. So-called blocking of inline scripts. Telling the web designers, put your scripts into one clearly marked place, tell the browser about this clearly marked place, and tell the browser not to execute anything else. That is a quite sensible, principled solution. The last point is authenticating origin. And we do not want to use public key infrastructure or anything like that. I've been saying this for 10 years. If you have heard the stories about DigiNota, you shouldn't believe me now. Second interlude, referring again to the same origin policy. Script can only connect back to where it came from. Your browser needs the IP address. The browser uses DNS and asks the authoritative DNS server to resolve the DNS name to an IP address. The browser trusts what it's being told. Trust is bad for security. Why? In this particular case, the client goes to attacker.org, which is run by the attacker. So the DNS server is run by the attacker. In one of the examples of a so-called DNS rebinding attack, the first answer is correct because when you first go to my evil web page, you really should come to my evil web page so you can get it into your browser. But you send your name to IP address binding with a short time to live. Then your script sits, waits, reconnects again. The entry has expired. The browser goes back to my evil authoritative name server. My evil authoritative name server returns your IP address and claims it's in my domain. So, lesson. Do not trust the DNS server on time to live. That's in essence the defense that was suggested back in 2001. The technical term in the browser community is pinning the entry. There are today on the web, as it has evolved, more sophisticated authorization systems where the DNS server tells the browser about the server's policy about which other hosts are acceptable. So again, you are visiting my evil server, and my evil server tells you all these other IP addresses, domain names, really belong to me. If you trust me, you've lost. Defenses, something like double checking, go back to the individual IP addresses, ask those machines, are you really in the domain attacker.org, related to reverse DNS lookup, related to some defenses suggested against bombing attacks in network security. If I had more time to talk about DNS rebinding attacks, I would point to the first attack published in '96, which really follows a very similar pattern. So you also see the wheel of reincarnation spinning around, people repeating mistakes that had been made in the past and forgetting about it. Last comment, asking me, the evil server, to sign, use cryptography, use digital signatures, does not buy you anything. Brandon Eich, Mozilla, at a seminar or after a seminar, made the remark, the reference monitor, which initially was buried deep down in the operating system kernel, is moving into the web page. My new attack model, 5 slides to go. Secrets are stolen not on the network, they're stolen in the browser, in the DOM, cookie stealing. They can be hijacked via the DOM. Cross-site request forgery is an attack I had not mentioned. They can be smuggled through the DOM, JavaScript injection attacks, JavaScript hijacking attacks, sorry. In that attack model, sending secrets over the internet is fine. It's not my problem. My enemy is not the old spy, it's the new hacker. In the past, the internet was insecure. The end systems were secure. Now my attitude is, the communication systems is reasonably secure. We have the crypto protocols to make it work. The problems are the end systems. So status quo in communications, internet traffic secured, focus moves from the network to the end systems, focus moves, as you had seen in the TLS renegotiation protocol, from the lower layer protocols, network transport up into the application layer to HTTP and above. Internet security, or security overall, I should say, moves from internet security, which to me is the old communication security, to the new web threat model. The infrastructure I need is not necessarily the infrastructure I need to protect transmissions. The infrastructure might be an infrastructure that tells me where to find a host with a particular name. With end systems, back 20 years ago, back 30 years ago, we were trying to have A1 secure operating systems. We didn't go down this route, and by now I can say it hadn't mattered. Even if it's done, even if you used the fairly good, well formally analyzed ALS3 microkernel as the basis of your operating system. It doesn't matter. The attacker does not need access to the operating system anymore. The attacker creates mayhem at the application layer, in your browser, in your web pages. So, security focus, down from the infrastructure, up into the application. Hence, I strongly agree with Brendan Eich, the reference monitor is moving into the web page. Computer security today. You remember in the past this was the security perimeter. The browser, probably already an application, at least in the early times with the early understanding of the web. Where is the security parameter now? Is it around the browser? Is it in the web page? But it's definitely no longer down here. So, computer security, as understood in the first edition of my book, doesn't protect you against dangers in the web. Network security, as it's traditionally understood, does not defend you against the major threats today. We have to move the line of defense from the infrastructure into the applications. If you want to misuse the paradigm of the castle, instead of retreating, we're moving out. It's no help staying within the walls. Current challenges, browser. Is browser security the new operating security? Oddly enough, common criteria. I still have not seen a protection profile for browsers. Access control mechanisms for Web 2.0, plugins, mashups, cross-domain requests, all very active. If you give me the extra minute. One of my success stories, Mark Curfey, MSc in Information Security, 98. At that time, he finished in 97. I moved to Microsoft in 98. He did his master thesis with me on some anti-security aspects. He told me all this night jokes about Microsoft he could think of, because that was unthinkable to go to an evil place like that. He was very successful, went to the States, started OWASP, the Organization for Web Application Security, moved to Microsoft. At an event of OWASP, I heard remark, Adobe. They are constantly introducing new features that introduce new security vulnerabilities. That's where the challenges are today. Also, in technical terms, interaction between layers. Take my TLS renegotiation story as a brief example. So, concluding remarks, securing the infrastructure is neither sufficient nor necessary. Always pleasing for a mathematician like myself to make statements like that. If the applications are critical, we have to secure the application. Last aside, today it is extremely fashionable to talk about the cloud as the new infrastructure for executing software, and it's also fashionable saying we have to secure the cloud. Is this true? Or do we have to secure the applications running in the cloud? That's the end. Thank you very much for your attention.